Hello, analytical human beings. This is Analytical Mr. Stark with an Analytic Trig lesson on proving trig identities. Wow, that took 5 takes. This is the second topic, but it's the fourth lesson of the series. And we're only going to focus on strategies. I have three main types of strategies with one proof that we're going to go through. So just to prepare your brain a little bit, I'm not going to share with you any new identities, and I'm not going to share with you any very unique ways to solve problems or equations or anything like that. I'm going to share with you strategies on how to prove identities and focus on one particular equation that we're going to go step by step, and we'll see each part of the process. So the first set of strategies I just call strategies 1. And I have 3 of them for you. The first strategy is this. The proof begins on one side. The proof begins on one side. I say just one side, not the left side, because we could start from either side. We could actually start from the right side and move left. The next strategy, the proof ends on the other side. Obvious? Maybe not. The third one's a little bit more unique. And it's this. The proof in between consists of a sequence of equivalent expressions. The proof in between consists of a sequence of equivalent expressions. Every step we take, each step is equivalent, but we've just moved closer to our goal. So as we prove our own identities or verify identities that are already proved for us, we'll be able to analyze both and identify if each step is equivalent or not. Next set of strategies, the second set. I also have 3. The first one is this. This is your advice, begin with more complicated expressions, or begin with the more complicated expression. Sort of reminds me when I try to do my tasks, I try to start with the hardest one. Well, if I have the energy to do so. But usually it's easier to do the hardest one first, because when you work more tasks, you get tired. So start with the more complicated one. Now this next one is completely separate than this. It's just part of these 3 strategies. And it's this. Convert every term to sines and cosines. Convert everything to sines and cosines, or sines and or cosines. So tangent could be written as a quotient of the 2. Cosecant could be written as sine. Secant could be written as cosine, as reciprocals. Okay, and then the third one is this. Combine fractions by finding a common denominator. Combine fractions by finding a common denominator. So we're using our algebraic skills on our tool belt. I don't just say common denominator here because it's not obvious that that's our goal, is to combine the fractions. All right, so I leave that in there so that we know, okay, we have 2 fractions and we're going to actually combine the 2 into a common denominator. All right, so that's strategies number 2. Now we're going to jump into an actual proof, which is, I don't know, I'd say that's a medium level, medium high. So here's the proof. Prove sine x over 1 minus cosine x is equal to this quotient on the right side. 1 plus cosine x over sine x. Now when I look at that, I think, that's kind of interesting. The sine looks like it flips to the denominator on one side to the other, and then the sign changes for cosine. So I think that's sort of interesting when I think about it. It's not really an identity that we're going to use. And now when I look at this, I don't see like the left side is harder than the right or vice versa. So I'm just going to start from the left side and try to take some legal steps here as we go through. So sine x over 1 minus cosine x, I'm just rewriting the first part of our quote proof. I use that term carefully, right? There's some bitterness from geometry, I know. And so this first step is actually not part of the strategies we've talked about already. I'm going to summarize this in just a moment with the third set of strategies. But when we see something like 1 minus cosine x or 1 plus cosine x, it gives me the hint that maybe I should use difference of two squares. So what I'm going to do here is multiply by 1 plus cosine x, top and bottom, 1 plus cosine x, which this whole thing is just 1. Okay, so that's a legal step to take. And so what I get is sine x. And I'm going to leave the top the same. Oops. But I will use the difference in two squares with the denominator. So cosine squared x. In other words, cosine x, quantity squared. Now just a quick thought about why I left the numerator the way that I did. I could have just multiplied that out and everything would have worked just fine, but I actually kind of know where I'm going, since I've done this example before, and so I'm going to save a little bit of ink or graphite here or electronic markers, and I'll just explain that step later as we get there. So notice what happens with the denominator is it's looking like one of the identities that we've studied in this particular unit. And remember, whenever we see sine squared or cosine squared or tangent squared, we think of the Pythagorean identities. So if you flip back to your identities, you'll be able to notice that sine squared plus cosine squared is 1, and if we solve that for sine squared, we get 1 minus cosine squared. So I'll replace that denominator with sine squared. So that looks like this. And again, remember I could have done this as like a 2-column proof and shown each reason for each step. Okay. The next step is just to do a little bit of algebra. So we have the sine x in the numerator and sine squared x in the denominator. It's just kind of like y and y squared. So one of them divides out, 1 from the numerator and the denominator. So we get 1 plus cosine x over sine x. And we arrived at the answer or the end of the proof pretty quickly. But let's say, just for giggles, we do this. Let's do this in red. Let's say we actually multiplied that numerator out, because that's kind of like what that's saying to us. Hey, multiply this out. Okay, so then we get sine x plus sine x cosine x. And that wouldn't be a wrong thing to do. It just wouldn't get you to the answer as quickly. You just have one more step. And so notice that we could actually separate that into two pieces, which is sine x over sine squared x plus sine x cosine x over sine x, sine squared. Okay, and that gives us, oh my gosh, maybe it's actually 2 steps more. So we get 1 over sine x plus cosine x over sine x. Okay? So that's actually the same as where we ended in this purple piece right there. So that red, everything in red down there is an alternative route that we could have taken just a little bit longer. So here we go, strategies 3. And just a side note, for this particular example, by no means is this comprehensive. Oh my gosh, if I were to give you every single example that would help you with all the proofs, you would be blue in the face. So here we go, third strategies. First one. Use a plus b times a minus b, which is equal to a squared minus b squared, to set up Pythagorean identities. Use difference of two squares to set up Pythagorean identities. Now that's exactly what we just did. Aha, I just realized I only have 2 strategies for you. Okay, and the last one is be mindful of the gap. No, of the target expression and favor manipulating or manipulations that bring you to the goal. I reworded that a little bit. Be mindful of the target expression and favor manipulations that help you achieve the goal. That reminds me of when I also do tasks, when I do some sort of project. Anybody can really work through a variety of projects. They could Google things, they could ask people and stuff like that. But there's something special that happens when somebody can do a project or a proof or a particular task, a task that is done very succinctly. So the word succinct, S-U-C-C-I-N-C-T, very succinct. It's very special. So you think about IKEA, how could they make the building of the furniture the most efficient through that process and give you just the best icons that help you with that? Well, maybe they're not the best, but they do pretty good job. Okay, well that's all I have for you. So if you're studying proving trig identities, this is the only content for this process. The rest of it just comes from practicing and getting familiar with more of the identities. So thank you so much for listening to this and checking out the example. And so I will leave you with that. Thanks a bunch.